welcome you in the lecture series of Basics of Communication Engineering, and it is tutorial 7th based on lecture 18 and 19. The question first is given xt is 10 cos 2000 pi t into cos 8000 pi t. What is the minimum sampling rate based on the low pass uniform sampling theorem? And repeat part A based on the band pass sampling theorem. So here it is given xt is 10 cos 2000 pi t into cos 8000 pi t. So we can represent it as 2 cos A cos B is equal to cos A plus B plus cos A minus B. So it will be 5 cos 10,000 pi t plus 5 cos 6000 pi t. So this signal is composite signal composed of two sine waves, 5 cos 10,000 pi t and 5 cos 6000 pi t. The highest frequency present in xt, it will be 5000 Hz. So as per the low pass sampling theorem, the minimum sampling frequency Fs, it will be equal to 2 Fm, or you can say 2 into 5000, so 10 kilohertz. So the sampling frequency, it is 10 kilohertz. And for the part B, two frequency components of xt are here. F1 is here, from here it is 300 Hz, and F2 is 5000 Hz. There are two frequency involved in this signal xt. So we can say here the bandwidth, it will be bandwidth of the signal, it will be f2 minus f1, and it will be equal to 5000 minus 3000, so it will be equal to 2000 Hz, because here the frequency f2 is 3000 and frequency for f2 is 5000. So then the sampling frequency, according to the band pass sampling theorem, the sampling frequency, it will be 2 fm by k, and you can calculate the value of k as it will be equal to fm by bandwidth, and fm is 5 and bandwidth is 2, so you can say it is approximately 2. So from here fs, it will be 2 into 10 kilohertz divided by 2, so 5 kilohertz. Now next question, find the Nyquist rate and the Nyquist interval for each of the following signal. The first signal is xt 5 cos 1000 pi t into cos 4000 pi t, and the second signal is xt is equal to sine 2000 pi t by pi t. Now the first part, xt 5 cos 1000 pi t cos 4000 pi t. 2 cos A cos B is equal to cos A plus B plus cos A minus B. So using this we will have xt will be 2.5 cos 5000 pi t plus 2.5 cos 3000 pi t, and the maximum frequency component in the signal, it will be fm is equal to 2100 Hz, or you can say it is 2.5 kilohertz. So the Nyquist rate or sampling frequency, it will be equal to 2 fm, or it is 2 into 2.5, so it is 5 kilohertz. And the Nyquist interval ts, it will be 1 by fs, or you can say 1 by 5 kilohertz, so it will be 0.2 millisecond. And the second part xt is sine 200 pi t by pi t. So in the second part, xt is equal to sine 200 pi t divided by pi t. Here the maximum frequency component in xt is fm equal to 100 hertz. So the Nyquist rate, Nyquist frequency, it is 2 fm, it is equal to 200 hertz, and the Nyquist interval, it is 1 by fs, or you can say 1 by 200, or it is equal to 5 millisecond. Now next question is, a band pass signal has a spectral range that extends from 20 kHz to 82 kHz. Find the sampling frequency. Here f1 is 20 kHz and f2 is 82 kHz. This is fm. And so bandwidth, it will be f2 minus fm, 82 minus 20, it will be equal to 62 kilohertz. The bandwidth is 62 kilohertz, so the sampling frequency fs, it will be 2 fm by k, and you can calculate k, it is equal to fm by b. fm is 82 and bandwidth is 62, so it is 1.32, or approximately you can say it is 1. So sampling frequency, it will be 2 fm, or you can say 2 into 82, it will be 164 kilohertz. Now next question, a signal xt cos 200 pi t plus 2 cos 320 pi t is ideally sampled at frequency fs 500 Hz. Draw the spectrum of xf of continuous analog signal xt, and draw the spectrum of x delta t, the ideally sampled signal. So you have to draw the spectrum of the signal xf and the ideal signal x delta f. So we have given xt is cos 200 pi t plus 2 cos 320 pi t. Since you know, if cos 2 pi f naught t is given, and the Fourier transform of this cos 2 pi f naught t, it will be 1 by 2 impulse function at f minus f naught plus 1 by 2 impulse function at f plus f naught. So we can say xf, if I will take the Fourier transform of this xt xf, it will be 1 by 2 delta f minus 100 plus 1 by 2 delta f plus 100, and plus, for this it will be delta f minus 160 plus delta f plus 160. So you can see this is the spectrum of analog signal xt. Here the signal will be at 100, minus 100, and minus 160, and plus 160, and the amplitude for 100 and minus 100, it is 1 by 2, and amplitude for 160, it is 1. So this is the spectrum at 100 and minus 100, amplitude is 1 by 2, and for minus 162 and plus 160, the amplitude is 1. So this is the spectrum of continuous signal xt. Now the second part is draw the spectrum x delta t. So the spectrum of x delta t, it will be x delta f, and you know, and the x delta f, it is fs, summation minus infinity to infinity x f minus nfs, and here fs is 500 hertz. So x delta f, it can be written as 500 summation x f minus 500n, and this summation, it will be minus infinity to infinity. So here we can represent x delta f it will be 500 xf plus 500 xf minus 500 plus 500 xf plus 500 plus 500 xf minus 1000 and plus 500 xf plus 1000 and so on. So this is the spectrum of the signal with amplitude 500, and this is the spectrum of the signal shifted version and shifted by 500 Hz, and this is also the spectrum that is shifted by left by 500, and the spectrum shifted by right 1000, spectrum shifted by left 1000, and with amplitude, all amplitude are 500. So the spectrum of the sampled signal will be like this. It will be the spectrum of your x delta f. This is the spectrum of the sampled signal, and this is 500 x f minus 500 second term, and this term, this is the 500 xf, the first term, the spectrum of the signal, and this is the second term, spectrum shifted by uh, in right by 500, and this is the spectrum shifted in left by 500. So this is third term, 500 x f plus 500. So this is the spectrum of instantaneous sampled signal. Now another question is, the signal xt cos 5 pi t plus cos 10 pi t is instantaneously sampled. The interval between the samples is Ts. Find the maximum allowable value of Ts, and to reconstruct the signal x delta t is passed through the low pass filter. So this sampled signal is passed through the low pass filter. Find the minimum filter bandwidth to reconstruct the signal without distortion. So here we have given xt is cos 5 pi t plus cos 10 pi t. So from here, the one frequency component f1 in this signal xt, it is 2.5 Hz, and other is 5 Hz. This is fm. So from here, the bandwidth of this signal is 2.5 Hz, and the minimum sampling frequency, it is equal to 2 fm, and so it is 2 into 5, 10 Hz, and the allowable sampling interval, it is Ts is equal to 1 by Fs, or 1 by 10 Hz, so it is 0.1 second. Now the second part, to reconstruct the signal, it passed through the low pass filter, and we have to find out the minimum bandwidth. So the minimum bandwidth of an ideal low pass filter, to reconstruct the signal without a distortion, it will be equal to the bandwidth of the low pass filter. It will be equal to the highest frequency component of the baseband signal, it is fm. So the bandwidth is equal to 5 Hz. Now next question is, the signal xt 10 cos 150 pi t is ideally sampled at a frequency fs 200 samples per second. Sketch the spectrum of x delta t. So xt is given 10 cos 150 pi t. Here xt is 10 cos 150 pi t, and so xf, it will be the Fourier transform of 10 cos 150 pi t, and it will be xf, it will be equal to 5, and impulse at minus 75 and impulse at plus 75. So the sketch of xf, it will be the impulse at plus 75 and minus 75 with amplitude 5, and the the sampled signal, ideally sampled signal, x del f, it is fs summation x f minus nfs, or we can write it is 200 summation x f minus 200n, where n is from minus infinity to infinity. So from here we can have x delta f, it will be 200 xf plus 200 x f minus 200 plus 200 x f plus 200. So this is the spectrum of the signal, and spectrum shifted to plus 200 and minus 200. So the spectrum or sketch of the sampled signal x delta f with sampling frequency 200 samples per second. This is the spectrum of the signal, and this is the spectrum of the signal shifted to 200 plus 200 and minus 200. Now next question is, a continuous time signal xt 5 sine 2000 pi t and 7 sine 4000 pi t is to be sampled. Calculate the minimum sampling frequency. So in this signal you have f1, it is 1000 hertz, and f2 is 2000 hertz. So there are two frequency components, f1 1000 hertz and f2 2000 hertz. So the minimum sampling frequency, it will be 2 fm, and so 2 fm into 2000, so it will be 4000 hertz. It is with the according to the low pass sampling theorem, and according to band pass sampling theorem, if we have the f1 and f2 components, so the bandwidth is f2 minus f1, it will be 1000 hertz, and value of k factor, it will be fm by b, so it is 2000 by 1000, so it will be 2. Now the sampling frequency based on band pass sampling theorem, it will be 2 fm by 2, or you can say it is fm, or 2000 hertz. So there is difference using low pass sampling theorem and band pass sampling theorem. But if the harmonics related result will be same, then both method will give you the same result. Now the question is, a signal xt 2 cos 6000 pi t plus 4 cos 800 pi t plus 6 cos 10,000 pi t is represented by samples. What is the minimum sampling rate for low pass sampling theorem and for band pass concept? So here from this signal xt we know fm maximum frequency component, it is 5000 hertz. So, as per the low pass sampling theorem, the minimum sampling rate Fs, it will be 2 Fm, or you can say it is 2 into 5000 hertz, it is 10 kilohertz. Now for the second part, for the band pass filter, if here you can see there are three frequency component, f1, f2 and f3. So f1 here is 300 hertz, f2 is 400 hertz, and f3 is 5000 hertz. So 3400 and 5000 hertz. So the bandwidth difference between maximum 5000 and minimum 400 hertz, so it is 4600 hertz. So from the band pass sampling theorem, the value of k factor, it is fm by b, it will be equal to 5000 by 4600, or you can say it is 1.086, or it is equal to 1. So fs will be 2 fm by k, or you can say 2 5000 by k, or you can say it will be equal to 10 kilohertz. So for the band pass consideration, or for the low pass sampling theorem. So from the low pass sampling theorem and band pass sampling theorem, the sampling frequency is same, 10 kilohertz. And this is the end of tutorial 7. And in the next lecture we will discuss about pulse amplitude modulation and pulse width modulation. Till then, thanks for listening this tutorial. Thank you.